Okay. So area of formula must be memorized. Okay. I think you already memorized during your school time, right? Okay, so what is the formula for the cube area? Not cube lah, it should be that one volume. M to the power of 3. Area. Area of a square. Yes. M2, okay? So, length times length, right? Who forget? Because it is important. Later, got circle. Circle. Area for circle. What's the formula? Pi R. Okay. Okay, pi R. To the power of 2. Okay, anything else? Square, circle, triangle. Triangle. Half times base times height. Okay. Okay, so from the area, later you need to know the volume. Okay, but now area first. Because the formula just now. Oh, wait. Formula just now, P equal to force per area. So area normally they don't give. They will give you the length or the radius or the diameter. If diameter, you need to divide by 2 to use the R. Okay, if not, divide by 4. Okay, so force, if they give, you can find force divide by area. But area, normally they don't give. They give the length or radius. Okay. That is why important for you to know the formula. So SI unit for pressure, the pressure or stress that arises when a force of 1 Newton is applied uniformly over an area of a square meter. That is what Pascal state. Okay, now we look at the example here. Someone steps on your toe, exerting a force of 500 Newton. On an area of 1 centimeter square. What is the average pressure on that area at atmospheres? Okay, so in this question, they already give you the area. No need for you to calculate because the toe is not a normal, not normal. It's not a standard area that you will know the formula, right? So, what you need to do, the 1 centimeter, you need to convert to meter. Okay, 1 centimeter to the power of 2. Now you convert to meter become, centi is 10 to the power of negative 2. Okay, I open whiteboard. You think first, what is the value? The centi is 10 to the power of negative 2, but remember you have to the power of 2 here. Create new whiteboard. Okay. Anyone have a type? Already calculate. No. The 500 Newton no need to change. We want to change the centimeter to meter. Meter square. Okay. Okay, got some answer from your friend here. 0.0001 meter to the power of 2. Wait. So here you look at the question. Question is 1 centimeter. So 1 times 10 to the power of negative 2 in bracket to the power of 2. Okay, in the bracket to the power of 2. So the 10 to the power of negative 2 will become 10 to the power of negative 4. Who don't understand what I say? Exactly like what Long Man Heng mentioned here. With a love here. Okay. Okay, so we will look at this in normal calculation, right? Kita got someone don't know. So, even simple we need to show. So, 1 centimeter, 1 times 10 negative 2. Okay, to the power of 2. So, 1 times 10 negative 4. Okay. So, if you 0.0001 meter to the power of 2. Okay. Okay. So need to convert this area to meter square first, then only save in every the calculation. Okay. Now, okay, for example here, for the area 1 times 10 negative 4. And then for the pressure is force divided by A. Force given in Newton already. If not given in Newton, how to do? If given in kilogram, kilogram cannot use, must convert to Newton. So must times with 9.81 to be exact. Okay, or you in the school maybe you use 10. Okay. So must times first, then only become Newton. So that Newton value put into here. So now we have finished until the answer here. So make sure the most important thing in this chapter is to convert the area to the meter. Then everything will be fine. 5 times 10 to the power of 6. Samuel answer already. Okay, correct. And then put the unit for pressure, Newton per meter square or Pascal, PA. Okay, either one also can. Okay, now we go to another example which is more interesting. Okay, why interesting? Because it involves the shoe of a girl. So compare the pressure being exerted on the heels of a person weighing 50 kilogram when wearing these two pairs of shoes. Okay, when you need to compare, you need to calculate the pressure for each. The stilettos, we call this stilettos, okay, the shoe with a very thin heels, okay, stilettos. This one, a big. Okay, so at the end of this, you need to measure this one better or this one. A1 or A2 is better for anyone to use? We don't want to wear something which hurt the people. When we look at the diagram, so already know A2 is more comfortable compared to A1. Okay, after we already look by our eyes, we need to prove it with calculation. So now is to calculate the A1. Okay, calculate the A1. Now the A1 here, this is round also or circle. So you must use area of a circle. So it should be pi r to the power of 2. Now this is given in diameter. Okay, given in diameter 1 centimeter. So the radius r will be half or 0.5 centimeter. Okay, 0.5 centimeter is the r. So now you count, but that one is centimeter. You need to convert that to meter. Okay, convert first. Okay, convert first. Don't refer to the slide. I know you have the slide. Don't refer first. You must try to do. Okay. For example, A1. A1 pi r to the power of 2. This one diameter. Okay, so here I put r equal to 0.5 centimeter equal to 0.5 times 10 negative 2 equal to cukup lah. Okay, use this. No need the equal some more here. Oh, finish already ah? Wait ah. Pi 0.5 times 10 negative 2 to the power of 2. For the exam, you must have step. Okay, because for example, 2 marks, 1 mark here, 1 mark at the last. Okay, so to the power of 2, 0.25 ah. Wait, I try first. Hmm. 78.5 7.85 78.5 wait ah 0.078 78.54 okay correct. Okay, so this you can press the engineering in your calculator, so it becomes 78.54 times 10 negative 6. Okay, that is for the area for the A1. Muhammad Saad, why your answer is 3.142? Samuel also 63. You do the right one or what? You do the A1 or A2?
Wait, I'm doing A1, miss. Let me double check.
Oh, okay. Okay, the rest follow my step here. If you don't know the centimeter, you convert at the side first.
Miss, I wrote the area as 7.854 times 10 power negative 5.
Yeah, times negative 5. Oh, yours is already pressure answer. Okay, we haven't do that. We are at the area answer yet. We are still here. Okay? Okay. Compare the pressure being exerted of the wheel of 50 kilogram. Okay. The 50 kilogram must convert to P equal to F per A. Okay, the formula. Okay, F, this one is not F. This one is mass. Okay, mass is 50 kilo. To convert to F is F equal to mg. Okay, so I need to show step by step for the first one because I don't know the rest will absorb faster or not. Okay, F equal to mg. So M is 50 multiplied by 9.81. Okay, I don't know they use 9.81 or 9.8 only. Wait, 9.807. Okay. So I will use the same as here, 9.807. So that the calculation will be exactly. Okay, 9.807. Okay. This one, first time we do slowly. Later we already know we can do faster. For 90 point.
Hi, Miss.
Yes.
Can I multiply by 10 instead of 9.807?
9.81 can. 10 cannot.
10 cannot.
Yeah, 9.81 can.
9.81 or 9.807 ah.
Yeah.
Okay.
Yeah. In the exam, we will state which one is the standard to use. For 90.35 Newton. Okay. After that, equal to this. Okay, then P equal to F per A. For 90.35 divide by this 78.54 times 10 negative 6 equal to 10 is too big different. Okay. Equal to 6.243. Don't see the P2 yet. We are still in the P1. Okay. 6.243 times ni tak muat tak. 10 to the power of 6 Newton per meter square. Okay, settle. So now we have settled the A1 and P1. Okay, now you do the same step for the A2. Okay, move back to the previous slide. Okay, the step here is for the A1. Now you do for the A2 also. Okay. So A2 do the same thing. Find the area. This one is not circle. This is rectangular. Rectangular is length times length. Okay. So much easier. No need to use the pi. Weight of the person is the same. Is one person only trying two different shoe. Okay. So now we will move to the A2. Because just now I use this color. A2 equal to 5 times 3 centimeter square. Wait centimeter square. So 15 centimeter square. Later need to convert this to meter. 15 times 10 negative 2 to the power of 2. You settle lah. Okay, wait 2 to 5 times 10 negative 4. Okay, wait, we check. Salah. 15 centimeter 1.5. Oh, the 15 no need to the power of 2. Is it lah? Wait 15 centimeter. There's no need, right? Now only the front is okay. 15 centimeter. Zero 0.15 meter square. Wait, I become blur lah. Wait 0.15 meter square. 0.15 correct 1.5 milli. Okay lah. Okay, after that the pressure is 490.33. 35 or 33 just now? 490.35 I put, but theirs is 33. It's okay, okay. Then okay, then you use the P2. P2 equal to F per A2. F for 90.35 divide by this 0.15. 0.327 times 10 to the power of 6 Newton per meter square. Okay. After you have you have calculate P1 and P2, both in 10 to the power of 6. So you know which one is more pressure, right? P1 is 6.2. P2 is only 0.32. So P2 is much lesser pressure compared to P1. Okay. So as a conclusion, sometimes the question will ask you what you can conclude from your calculation. Okay, you need to give one conclusion. So stilettos exert more pressure on the heel compared to chunky heel shoe. This one chunky. More surface area, less pressure, and vice versa. Okay. But actually, this calculation doesn't involve the front, right? This also need to be counted, suppose, to be more exact. Not only the back, the front also must count. Okay, so in designing the shoe or other thing, you need to take care of other area which is involved. Not only the heel, there is in front area also for calculation of pressure. This is not exactly the real answer for the pressure. A1 has less surface area, so more pressure. Yeah. Because from the eyes you can see this one very small, this one very big. This one is about the same as this. If the front is assumed the same area, then can count the back only. Okay, can count the heel only. If not assumed as same, then you must calculate all. Okay? Okay. Next, we will go to another example. Okay, still under Pascal principle. A change in pressure at any point in a confined fluid is transmitted everywhere throughout the fluid. So this is another statement for Pascal principle. Okay. So application, where to use it? Why this one come out? Okay, application is where you can use this principle. This Pascal principle can be used as the hydraulic lift, in the hydraulic brakes, or in the hydraulic control in airplanes. So there are three applications given here in this slide. Okay. So hydraulic lift. Hydraulic lift is here. Okay. So for example, you apply force to the F1, it will go to the F2 here to lift up this vehicle. The applied force is transmitted to the piston of cross-sectional area A2 here. So A2 here is F equal to P equal to F per A also. So here also F1 equal to P. P equal to F per A. So when we know that the pressure is transmitted to another one, so this is equal to this. So in mathematics, changes of P at point 1, okay, this one, equal to changes of P at point 2. Okay, so at point 1, formula is F1 per A1. At point 2, F2 per A2. Therefore, to find F2, we can use mathematical method, transfer this to the right side and become the formula like this. Okay, other than this formula, F1 per A, okay, we have another formula which involve the distance. D1 is the distance to push the piston. This one, D2 is the distance to push F2. Since liquid is incompressible, the volume of displaced fluid is constant. Therefore, A1 D1 equal to A2 D2. So this is another fixed formula rather than this. On top of this, you have another formula, this one. So when to use this and when to use this one? Okay, whenever the question have given you the D, then you need to use this one. Depends on the parameter that they give in the question. Okay, if you are limited to this formula, later don't have, all the area don't have, force don't have, then need to use this one. So you cannot limit yourself in doing any calculation by using one formula only. Okay. Next, the work done pressing the smaller piston equals to the work done by the larger piston 2. So work is equal to W equal to F1 D1 equal to F2 D2. This is another formula, got 3. Okay. Okay. So by using the formula just now, try to answer this example here. In a hydraulic lift, if the radius of the smaller piston is 2 centimeter, okay, why they give you the radius? To calculate what? Why they give you the radius? Same like just now, okay, to calculate the area, they give you the radius. Okay, smaller piston is A1, radius is 2 centimeter. This later convert to meter also. Okay, radius of the larger piston, this one is 20 centimeter. Okay, 20 times 10 to the power of negative 2 meter. What weight can the large piston support when a force of 250 Newton is applied to the smaller piston? So this is F1. Okay, 250 is F1. F2 need to find. But they don't ask you force, they ask you weight. Okay, so later from the force, you need to convert to kilogram, which is weight. Okay. Can try to do this. First, you calculate the area first. Okay, because they have given you the radius here, calculate the area. Okay, try to do. 2,500. Already calculate. For the which one? A1 or A2, Sultan Ranja? A2. Okay. So 20 to the power of 20 times 10 to the power of negative 2. To the power of 2 some more. Okay. Okay, try to do. So for the A1. A1 is the small piston. Pi r to the power of 2. R equal to cm 2 times 10 to the power of negative 2 meter. Okay. So pi yes, who's that? Substitute this, the R already convert to meter. Hmm. $1.25. The rest count or not? 1.26. 256. Leave it to 4 decimal first. Only the last one is 2 decimal because later, if not, not so accurate.
Miss, I don't think you have to make it so complicated because since the pi will eliminate each other, you only need to compare the ratio. So just use 20 divide 2.
Yeah, also can. But there are other question later which you cannot cancel. Okay, for this type of question where you can cancel is fine. Okay. Any? Okay, so since the F1 per A1 is equal to F2 per A2, so F2 equal to This one cancel with this times with F1, 250. Okay. Okay, but then this is force, right? Not the weight. When the question asks for weight, you need to divide this with 9.81 actually. Okay. So this is the answer if they ask you what is the force of the bigger piston, larger piston. Force of larger piston, this one. But weight, actually, weight you need to divide by 9.81. Okay. Next, weight in Newton, weight in kilogram.
This weight is in Newton, mass is only in kilogram.
Oh, weight in Newton. Okay, okay. Okay, mass in kilogram. Sorry. Okay, now we look at the next to this. In the previous example, A2 per A1 equal to 100. It was found that F2 per F1 is also equal to 100. If the larger piston needs to rise by 5 cm, how far must the smaller piston be depressed? Okay, so now, just now we have another formula, right, to use the D. Work done pressing the smaller piston equal to the work done by the larger piston. F1 D1 equal to F2 D2. So now they ask you D1 is how much? D1. How far must the smaller piston be depressed? So D1. D1 equal to F2 per F1 times with D2. So F2 per F1 already stated here 100 equal to times with D2. D2 is 5 centimeter. So since D2 is in centimeter, leave the D1 also in centimeter. Okay. Okay. So we take a break first for 5 minutes before we enter the gravity effect on fluid pressure. Okay. 10 minutes. Okay. Okay, is everyone here already?
Yes.
Longman Heng. Okay, since everyone already here, so we will look at one video first to ease your
from scales, what are you actually measuring? Well, if you said weight, like most people would, then you're sort of wrong. Kilograms are a measure of mass, but the scales actually measure the force of gravity on your mass. So they do actually measure weight, but this should be in units of force, newtons. Confused? Keep watching. This is a 1 kilogram bag of sugar. Grams and kilograms are units of mass. Mass is a measure of how much stuff is in something. This bag contains twice as much stuff. It has a mass of 2 kilograms. It would be wrong to say the bag weighed 1 kilogram or 2 kilograms, as weight is a force caused by gravity. To measure the weight, we need a spring balance or force meter. This is a force meter, or a Newton meter. It shows the weight of something hung from it. Let's add the bag of sugar. It shows the weight is almost 10 newtons. Can you remember the equation that links mass with weight? Remember F equals ma, where F is force in newtons, m is mass in kilograms, and a is acceleration in meters per second. We can rewrite this a little as W equals mg, where W is weight in newtons and g is acceleration due to gravity. On Earth, g equals 9.8 meters per second. So the weight of the 1 kilogram bag of sugar is 1 times 9.8, which equals 9.8 newtons, as the picture shows. Often in everyday life, we use the word weight, when in fact we mean mass. The bag of sugar has a mass of 1 kilogram, but a weight of 9.8 newtons. Now let's take this bag of sugar to the moon. The moon is much less massive than the Earth, and so has a lower gravity. On the moon, g is only 1.6 meters per second. See how the weight has dropped compared to when it was on Earth? But notice, we still have the same amount of sugar. There is still 1 kilogram of stuff. The weight has changed, but not the mass. Jupiter, the gas giant, has a g value of 25 meters per second. Can you work out what the force meter would show for the bag of sugar here, assuming there was a solid surface to stand on? The sugar now has a weight of 25 newtons. But don't forget, we still have 1 kilogram of sugar. That hasn't changed. Do you remember gravity? Watch this video. An object thrown away from the Earth will experience a force towards the Earth which slows it down, stops it, and the object accelerates back towards the Earth. This acceleration is due to the Earth's gravitational force and is written as a little g. It's also known as the gravitational field strength. To stop the apple falling, so to prevent the gravitational force pulling it towards the center of the Earth, a force is needed that is equal to this gravitational pull. Remember this. And on Earth, G equals 9.81 meters per second, or approximately 10 meters per second. Okay, back to mass and weight. Remember that mass is a measure of the amount of stuff in an object and gives a measure of how difficult it is to get moving or to stop it. It never changes. For example, my mass on Earth is 56 kilograms. On the Moon, I would still have a mass of 56 kilograms. The acceleration due to the Earth's gravity is measured in meters per second, or it can be measured in newtons per kilogram, as it's a force exerted on a unit mass. So let's now use this lovely equation to find my weight. Weight is the force due to gravity, and that depends upon the masses of the two objects that are attracted. On Earth, my weight is mass times gravity, so roughly 56 kilograms times 10, which is 560 newtons. But what about on the Moon? The gravitational acceleration on the Moon is only 1.6 meters per second. I hope you got 89.6 newtons. So, you would feel very light on the Moon, and if you try to walk, each step would send you leaping away from the surface. See how gravitational field strength changes on the surface of different planets. This is because the planets have different sizes and masses. The largest planet, Jupiter, with the
Okay, enough about the video to just to highlight the gravity. Okay, gravity. So gravity effect on fluid pressure. Gravity makes fluid pressure increase as we descend and makes fluid pressure decrease as we ascend. So they are descending and ascending. Density of a substance. Density is rho equal to m per v. This is another formula. Okay. Next, for a cylinder of liquid. This is a cylinder container, and then you drop one. So when you drop the object, there is a force from top and from bottom. 1A, F2 equal to P2A. So also you need to use the area as what you did just now. Okay, on top of that, we have weight equal to G equal to rho GV. Okay. So applying Newton's second law to the fluid cylinder, which is equilibrium, so we have a total force equal to P2A minus P1A minus W equal to 0. Then substitute the W equal to rho GD times A. After that, all A is factorized. Okay, here got A factorized. So factorize, bring to the right side, it will become 0. 0 times the A. Okay, after that, GD. Okay, this formula is provided in the formula sheet, but must know which one to take. So, if then P1
you're
equal to
lagging.
PATM. Lagging.
Yes.
Still connected. Maybe for a while only. Okay. So this is the formula for anything which is inside the fluid. Okay. We must know which formula to use. So if the top of the fluid column is placed at the surface of the fluid, then P1 equal to P ATM if the container is open. So it will be different if the container is closed. Okay. Pressure at depth D below the surface. Okay, this is the depth. Below the surface of a liquid open to atmosphere is P equal to P ATM plus rho GD. Okay, so by looking at this, it is hard to absorb, right? Then we will go to the example. At the surface of the freshwater lake. Okay, so it is important to know whether it is fresh water or sea. Sea will have different density. Okay, that is why you must read carefully whether it is which type of water. Fresh water different density compared to the sea. Sea because it's salty, right? So sea will have different density. Density value will be given in one table. Okay, density value will be given in one table. So you need to find out, for example here is given, the density of water is given in the question itself. But some of the question, the density is not given in the question. You need to refer to a table. Okay. Oops. Okay. So for example, water density. For example, seawater, density of seawater is 1.020 to 1.030 gram per centimeter cube. Whereas density of fresh water is 1.0 gram per centimeter cube.
You are lagging.
Still lagging. Which table? Table will be provided in the formula sheet later. Okay, Muhammad Saad. Table not here. So in the table there are many other density value. Okay, so for example, what is the pressure increase when descending 35 meter below the surface? Okay, here mentioned at the surface. Surface is at the top. At the top of the lake. Okay, at the surface of the lake, the pressure is this, 105 kilopascal. So they want to know what is the pressure after you have swim at the bottom a bit 35 meter below the surface. Okay, so just now here, right? So they already provide you the D. D is the distance from the surface go to the bottom. Okay. So to answer part A, you must use P equal to P ATM plus rho GD. Because they ask you what is the pressure increase. Actually should be how much is the pressure increases. right? When descending 35 meter below. So, changes of P will equal to P original minus P ATM equal to rho GD. So, how much is the rho? Rho is the density. Density is 1000 kilogram per meter square and meter cube. So 1000 substitute in the row. G is 9.8. So G how much to use will be mentioned in the exam also, whether 9.8, 9.81 or 9. Just now we use 9.807 or what just now, right? Okay. So that will be mentioned. Okay, then the D, distance given in the question is 35 meter. If this is in centimeter, convert to meter first, then only put in this calculation. Okay, after you already get it in kilopascal, okay, you can convert it to ATM. How to convert? How to convert from the previous slide? P original just now, so you plus with the, P ATM is equal to P minus rho GD. Oops. Okay, so you will get 3.43. This one already have P minus P ATM, 343 kilopascal. Okay. If you don't want to put all the unit during the calculation, is okay. You can put in the last final answer only. So for the table will be provided in the exam, in the appendix. In the formula sheet, it's a booklet, not the, wait, I try to look. It's a booklet for the exam. Exam. List of constant. Oh. Okay, for example, during the final exam, the formula we put at the back of the question, okay, or in another file for the appendix. So these are the list of constant. For example, density of water. If only density of water is required or is asked during the exam, then it will be just like this. If there are other questions which is related to seawater or other liquid, then it will be in a table. Table form, something like this. This one is the table for speed of sound. Okay, it depends on the paper. Paper have or not. Okay. For example, for our fluid principle, chapter 3, the formula provided just now, you already do this. P equal to FA, AD equal to AD, F equal to FD, rho equal to MV, and now we are under P equal to PATM plus rho GD. So lists are according to chapter also. Under fluid, there is some more at the back here. Okay. So for the chapter 4 under elasticity is until here. So all the chapter formulas are in the box, so that student can easily find. If not, if we already mix all, then it is hard for them to find. Okay, so formula is easy to find. Okay, table will be provided if necessary, depend whether have or not the question regarding other density. If, for example, just one, it will be in that question itself. Okay, since in the final exam we have 4 question, right? 4 question and compulsory to answer all. But we have many chapters, so some of the question are sharing chapters. Okay, sharing chapters. For example, one question can be a sharing of fluid principle with another principle. Okay, so from my experience, student normally can score the calculation part. But for the theoretical part, maybe they are difficult for them to create the sentence unless they can copy paste from internet, right? Okay. So next is number B. What is the increase in force of a diverse eardrum if the area of the eardrum is 0.6 centimeter square? Okay. So now want to measure the increase, how much? Okay, so changes of F is equal to changes of P multiplied by A. So changes of P is from the previous calculation. 20.58. Okay, so Ranja. So changes of P. Most of the question are related to the previous section. So first section, calculate carefully. Okay, even though this one is wrong, for example, this one is wrong, you calculate become 4 point something, for example. Then you use this back here, even though the value is wrong, but you still have the working marks, provided the working are correct. Only the substitution are wrong, right? So for example, here got 3 marks, but because the last one is wrong, so you will get 2 marks. Now they are becoming more strict. For the formula which is provided already in the formula sheet, which you never modify. Okay, formula which is provided and not modified by student. Formula will not have any marks. Last time for the first line, for example this one, you take the formula directly from the formula sheet and then you write. So you will get 1 mark for the formula. Now since it is online also, we are advised to have a stricter marking scheme. So no marks for the formula which you take directly. If you need to modify the formula, then you will get 1 mark for the formula that you modify. There are certain questions that you need to modify. Okay. Okay, so for this, it is changes of P times with A. And then A, this is 0.6 centimeter. After convert to meter, becomes 60 times 10 to the power of -6. So most of the student, they will lose mark when converting. practice at home, they will have a wrong conversion. After change from cm to meter, wrong. Then here substitute wrong, here also become wrong answer. So you must have a lot of practice on your conversion to the SI unit. Okay. Next is measuring pressure. How do we measure the pressure? We can use barometer. Barometer is widely used weather instrument that measure atmospheric pressure or air pressure or barometric pressure, the weight of the air in the atmosphere. Okay, which looks like this diagram here. About 3 feet height with one end open and the other end sealed. So when sealed here, you will have a vacuum area here. This glass tube sits upside down in a container called the reservoir, which also contains mercury. Okay. The mercury level in the glass tube falls, creating a vacuum on the top. The first barometer of this type was devised by Evangelista Torricelli in 1643. So in future, maybe you can make one device and name after you. Okay, then you will be under the scientist category. Okay, you intend to do that or not? At first, you can enter journal first, your name. Enter certain journals. After many research that you have done, you will be, maybe you will do PhD and you end up inventing one formula. Who knows, right? If not formula, you can invent a device. Okay? That is why you learn all this. For example, the atmosphere, whether it is healthy or not, the air, right? So nowadays we can put a sensor to detect whether it is healthy or not. Okay, because sometimes got haze or sometimes got burning from other country and come to our country. So we can measure all that. Okay, why we need to measure? To prevent people from getting sick. So if it is not safe, the environment, the air is not safe, then it is advised in the news for people to stay in house. Okay, no need to go office, no need to go playground or exercise outside because it is not healthy. Okay, so by learning all this, that type of sensor will be invented. Okay. Okay, so from the picture here, you have a vacuum area here. At the vacuum area, the P will equal to 0. Then after that, there is a mercury also at the bottom here. Not only at this, inside this tube, also got at the bottom. The atmosphere pushes on the container of mercury, which forces mercury up the closed inverted tube. The distance D is called the barometric pressure. Okay. Sometimes there are diagram given and then you are needed to label. Label the biometric pressure location. Then they will put A, B, C, D, right? So you just need to label whether A, B, C. No need to draw back. Okay. There are some sort of question like that also. If you can refer to the slide, it's fine. If you cannot refer, means you need to memorize where is the distance. Okay, so distance is until surface only, not until at the bottom here. Okay, from the vacuum surface to the surface of here. That is the distance called barometric pressure. From the figure, PA equal to PB. So pressure inside the tube here is equal to the pressure outside with the same distance, equal to PATM. And PA equal to rho GD. Okay, formula rho GD also already used before. Another device which is used to measure pressure is called manometer. Just now barometer. Okay, manometer, the difference is it is U-shaped tube that is partially filled with liquid. Okay, partially filled. Only one area filled with liquid, the other area filled with gas. A container of gas is connected to one end of the U-tube. So gas put at one area, one more put the liquid. If there is a pressure difference between the gas and the atmosphere, a force will be exerted on the fluid in the U-tube. This changes the equilibrium position of the fluid in the tube. So suitable for low pressure measurement, but impractical for measuring higher pressures due to length of liquids, columns required. Okay, because if higher pressure, later not enough, the space. Okay. So there are two different measuring device for pressure, barometer and manometer. Next, for the calculation, at point C. Okay, in the barometer just now got how many points? Still remember or not? Barometer, how many points? For pressure. Anyone can answer in the chat? Forget already. Aiyo. Okay. This one is barometer. Got 2 points only. PA and PB. Okay. No PC. PC don't have. Okay. Barometer have 2 pressure point. PA is inside the tube. PB is outside the tube but at the same surface. Okay. So for the manometer, we have the third point, which is C. Okay. In this, we have PB, PB prime, and PC. But PB and PB prime is at the same level, so PB is equal to PB prime. Okay. The pressure at point B is the pressure of the gas. Okay. Here, right? Here, pressure at point B is the pressure of this gas. There is no liquid here. So, PB is equal to PB prime equal to PC plus rho GD. So, we need to know this distance only. Other distance, we don't care. Okay, we need to know this distance D to substitute here. So, PB minus PC equal to PB minus P atmosphere equal to rho GD. then P gauge equal to P absolute minus P atmosphere. P gauge equal to rho GD. So finally, P gauge equal to rho GD. Gauge pressure is zero reference against ambient air pressure. So it is equal to absolute pressure minus atmosphere pressure. Okay. So now we look at this example. A manometer is attached to a container of gas to determine its pressure. So here already mentioned manometer. Sometimes the picture is not given in the question. So you need to imagine manometer or barometer. Okay. Barometer is different. Not U-tube. Manometer have U-tube. So before the container is attached, both sides of the manometer are open to the atmosphere. So you imagine just now the U-tube is open to atmosphere both. After the gas is attached, okay, so one area put gas. One of the U-tube just now, got two, right? So one we put gas. The mercury on the side attached to the gas container rises 12 cm above its previous level. What is the gauge pressure of the gas in Pascal? So gauge pressure just now use the formula rho GD. Okay, so this is the picture. Okay, so at first it is after mercury is there, mercury attached to the gas container rises 12 cm above its previous level. So at first here, now increase to here. What is the gauge pressure? So using the formula rho GD. Okay, so rho is 13,600. Okay, so rho is density. Wait,
Miss,
yes.
may I know why did they use 0.24 instead of 0.12?
Yes, miss. Why is it
This
0.24?
the D must follow this. So 12 plus 12. Okay.
But miss, they only said it rised 12 cm.
Hmm?
Oh wait.
Rises 12 cm above its previous level. Previous level not mentioned.
Oh, okay, miss.
Excuse me, ma'am.
Yeah.
Ma'am, why it is a negative 0.24 negative?
Negative.
Yes.
Oh, in the previous slide. Wait. Negative signs are usually omitted. So actually absolute pressure minus atmosphere pressure, later you will get the negative. Okay. But later in the calculation don't have. See. They have. You know.
Excuse me, ma'am.
Yeah.
Why it is negative? I didn't understand.
Because rises up. If go down, just now the one in the swimming pool, right? Just now, not in the swimming pool. In the lake. Okay, wait. Open back the one with the lake. This one, right? So this one, after he go down, the D go down 35 meter. If go down, okay. If go up, negative. I just this one. This one rises up. Okay. If same as the yeah, who's that? Yeah.
Then why we have not chosen 12 instead of 24?
Why it is not 12 and it is 24?
Yes.
Again, follow the sentence here. After the gas is attached, the mercury on the side, this one, attached to the gas container rises 12 cm above its previous level. So previous level, it should be equal.
So Miss, we use 24 because we're just finding the dot pressure, right?
Yeah. It should be stated here. Actually, it should state here the previous level is how much, right? But here don't mention previous level how much. So you also not sure need to add with the previous the 12 or not. Correct or not?
So Miss, if they say change in pressure only, we use 12, and if they just ask pressure, so we use 24 lah. Is it like this?
Yes.
Hi, Miss.
Hi Tong.
How you get 13,600?
It's from a table, Tong.
A table?
Yeah. Wait. I show you the table. Wait. There is a table for the density. Okay. It's the table. Density of mercury. Okay. Wait. Okay, this is the table. So for mercury is 13.6 times 10 to the power of 3, the density. Okay. So table for the density will be provided, depends on the question. So this 13,600, wait, I check in the, you have not. Density of water. Sometimes given in the question itself also, the density. So don't worry, the value will be given. For example, if you need density of lead, Then it will be 11.3 times 10 to the power of 3. Okay, just now we have used fresh water density for the lake, which is 1 times 10 to the power of 3. So table must be provided if the question is related. So this 13,600 is from the table for the density. Is fixed value. So 13,600 times with G 9.8 times with the D 0.24. Okay. Next, they will ask you what is the absolute pressure of the gas in Pascal. Okay. For the absolute pressure, formula is P gauge plus with P atmosphere. Okay, P atmosphere is already given in the question. Okay, if not given, it will be in the list of constant also in the formula sheet. Okay, so be careful. Sometimes in the question not there, but you must check in the table or in the formula sheet. So here 101 plus with negative 32. So absolute pressure becomes 69 kilopascal. Okay. Okay, next is the Archimedes principle. Okay, just now we have learned Pascal principle only. Okay, now we enter Archimedes principles. Archimedes principles mention that the buoyant force is equal to the weight of the displaced water. So when you put one object inside the water, for example, the water which flow into this bowl, the water flow is 3 pounds. Okay. After water finish flowing, it will stop. So 3 pounds of water is equal to this object weight. Okay, it's the same. So there are some students who use this principle for making the assignment. Have I shown you or not? I have shown or not some of the assignment?
Yes, miss.
Okay. So that is a simple way of doing experiment. Okay. But then instead of just using one object, he can use 3 different objects, because in one experiment, you must have a table of result. Okay. Normally you do experiment in school also, there is a table of result. Okay, so table of result, for example, one is 300 gram, another one 600 gram, another one 900 gram. So try to make few object. Then you will have at least 5 row of result. Okay. Because in all experiment, after the result of table, you need to come up with the graph, which you use the Excel, right? All the data enter in the Excel, then you can generate a graph. So if you have one only or 2 data, not enough to make the graph, not suitable for making experiment. Okay, so be careful of that. I will also talk about the experiment later. Okay, since we haven't finished the fluid principle experiment, the question I cannot give you yet. Okay, after finish fluid principle, then only you use it in the assignment. Then only can hand out to student. Okay. Okay, don't worry. The assignment will be end of semester, the submission. Okay, 1 or 2 weeks before submission, you can demonstrate to me. If you don't want to demonstrate online, in live, maybe you shy or what, you can take a video for backup. Okay. But if you demonstrate online during class, then your friend can learn from it. Correct or not? I don't think your friend will be asking question also from my because from other classes previously also, students shy to ask question when their friend are presenting. Since they are scared, they will be asked also. Right? So can also help each other. Okay? Okay, so this one, when you drop some object, the water will fill up. So Archimedes' principle mentioned fluid exert an upward buoyant force on a submerged object equal in magnitude to the weight of the volume of fluid displaced by the object. So this is the object. There is a buoyant force, which is F2. So total force on the block due to the fluid is called buoyant force. FB is equal to F2 minus F1. So FB is equal to rho GV. So in this, we need to know what is the rho also. Okay, the density. We need to know to substitute into the formula. Okay. Next, the magnitude of the buoyant force is FB equal to F2 minus F1. So P2A minus P1A. Okay, since the object got one up and the down, so P2 minus P1 times with A. So P2 minus P1 equal to rho GD. If one of the parameter is missing, you can find. Okay, so the result is rho GD multiplied with A equal to FB, buoyant force. FB is buoyant force. So buoyancy of an upward acting force causing by fluid pressure that keeps object afloat. So volume of object is equal to volume of liquid displaced, like the picture just now. Apparent weight is equal to weight minus weight of displaced liquid. So it's the same just now as the one in the first picture. So by using the Archimedes principle, it is suitable to use for this. A flat bottom barge loaded with coal has a mass of 3 times 10 to the power 5 kilogram. The barge is 20 meter long and 10 meter wide. So when they give you the long and wide, you can measure you can calculate the area. It floats in fresh water. This one also important. If not fresh water, sea water different density. Okay. So fresh water just now is 1 times 10 to the power of 3. What is the depth of the barge below the water line? So first you need to draw this picture to understand more. This is the free body diagram for the barge. Force go up is the force of the buoyant force, and then there is a weight which go down. Okay. So total force is equal to force of buoyant minus weight equal to 0. Force buoyant equal to weight. So Buoyant force, just now from previous slide, we have seen that F equal to mg, m equal to rho v, okay, multiply with g. And then finally, if there are distance given, distance will be mb per rho wa. So m is given here. Mass is 3 times 10 to the power of 5. And then rho. Rho is not given in the question. So fresh water, you must refer to the table. And then you will know the density is 1000 kilogram per meter meter cube. Okay. Then multiply with A. A also not given. A must multiply this length. 20 meter multiply with 10 meter. If in cm, convert to meter first. Then only you multiply, put here. After you calculate everything, you will get 1.5 meter. That is the depth of the barge below the water line. Do you know what is water line? The surface, okay? Okay. Okay, since we have too many principles which we learned today, we will continue it in the next class. But we must do the calculation in tutorial first for the Pascal. Okay. So Pascal and some of the Archimedes we can do. Okay, peace. So this subject enter the physics. Okay, previously chapter 1, chapter 2 is more to chemistry. So now we have entered the physics area. Okay, so when you go back, revise on the principles and Archimedes. We will do the calculation in the tutorial class. Wrong class, sorry. EM. ESC. After 15 minutes, about to finish, must extend this, if not, cannot. Okay, from now on, you can try to find out what experiment you can do for the have entered the fluid principle. You can see some YouTube videos to help you in doing the assignment also. Okay, just keep some information in one folder.
Excuse me, ma'am.
Yes, Muhammad Saad.
Ma'am, for the experiment, what things will be required in order to do the experiment?
What?
What things will need to
What
carry
kind?
out the experiment?
Oh. Okay, wait.
Can you message on general chat?
Chapter is this chapter only. Only this chapter for the assignment. Okay,
No,
sample. Sample. This one have scan all. One episode. Wait, I save this first.
So what things will gonna required things.
Okay, for example, this one is a model done by student. Okay, So in the assignment, you need the procedure. Like all the experiment in the lab also, you need some procedure. Procedure must be in passive voice. Okay, this one sample, not necessary you follow this, okay? As long as it is using fluid principle. Can be, this is Bernoulli. Wait. This one, application on Bernoulli. Okay, for example, a model was built in figure 10. Okay, after that, the hole is labeled, measured and marked. Okay. After that, diameter of the pipes for the holes. So now, diameter should be the same or not? For this type of experiment, since the bottle have a changing. Huh? Same. Yeah. Because the area are different, you see. This one might be different from this. This one a bit smaller the area compared to this one. So to measure this area, you need to measure. Okay. This one also. Area here smaller than here. Then this one smaller than this. This one even smaller. Then to make another one, he already used another pipe to make sure that this area not same as this area. So he will have 5 different area. Okay?
Excuse me, ma'am, we have question on Moodle. Have you uploaded the question on Moodle?
No, question cannot upload until finish principle of liquid. Just now what did we mention? Cannot yet, huh? Okay, so after that, you will have a result. This is what I mentioned just now. The result for the experiment should have a minimum 5 row. Okay, minimum 5 row. Sample only this one. And then got calculations. And why have many calculation? Because he calculate for different tube. Okay. After that, discussion. Experiment was on Bernoulli. You haven't entered yet, Bernoulli. Okay, you only until Archimedes. Also haven't finished calculation. That is the sample, then the reference. Okay. So for now, you just check out the what experiment can be done. You are as if you are making one experiment for other people to use. Okay, for other people to use in understanding the principle. But don't do two, only one. If you choose Pascal, Pascal only. If you use Archimedes, Archimedes only. Okay, cannot choose two. Okay. Any more question?
I haven't marked attendance yet, miss.
Huh? Who's that?
Pitakon.
Pitakon, you really cannot scan many times.
No, I mean, I went toilet and then come back, then you already like.
Oh, okay. Pitakon. Okay, the rest already scanned. Okay. So just look at any of the style of experiment. Okay, the objective is for other people to use your document. Yes?
Can we leave?
Yeah, can. Okay, you can leave. We will talk again about the assignment in other class. Okay, thank you.
Okay, thank you, Miss.
Okay, welcome.
Thank you, Miss.